Back to my channel. So how do you solve this integral? So this integral we can really start off by reimagining this integral. So this -1 raised to the power x, I am going to use the Euler's formula. You know the Euler's formula, e to the I of theta is the cosine of theta plus I sine of theta, right? We know this. And then if we have e to I of pi, that is going to be what? Cosine of pi plus I sine of pi. What is cosine of pi? Cosine of pi is -1 and sine of pi is 0. So ei pi is going to be -1. So in place of our -1 in the integrand, I'm going to replace that with e to the I of pi. That is by courtesy the Euler's formula. So our integral really reduces to the integral from 1 to 2 of e to the I pi all raised to the power x plus the ln of x, all this one dx. So the integral from 1 to 2 of e to the I pi x plus the ln of x dx. Okay, so we are now ready to integrate them term by term. The integral from 1 to 2 of e to the I pi of x dx plus the integral from 1 to 2 of ln of x dx. So this one is just integrating the differentiating the power and differentiating the power with respect to x is I pi, then we divide. That is going to be 1 over I pi or pi I, like this, and then e to the power I pi x. Then we are integrating that from 1 to 2 plus the integral of ln of x, which is x ln of x minus x, integrating that from 1 to 2 like this. So this one really we can use integration by parts, d and I method. So we normally differentiate the ln of x and integrate just 1. So differentiating this is 1 over x and integrating this is x. So we just multiply the diagonal terms plus negative. So multiplying the diagonal terms, we have x ln of x minus the integral of the product of the horizontal terms, that is going to be 1 over x times x dx. So that is really x ln of x minus the integral of dx, or 1 dx, which is x ln of x minus x. So if we integrate ln of x, we are going to get x ln of x minus x. That is what we have here. So this is just for the purpose of illustration. Okay, so this is how this one can be broken down. So we can plug in our limits really. So that is 1 over pi I e to the I pi times 2 minus e to the I pi times 1, which is I pi, like that, and then plus 2 ln of 2 minus 2 minus the lower limit, which is 1 ln of 1 minus 1, like that. Okay, so this is 1 all over pi I. This is e to the 2 pi I. E to the 2 pi I minus, this is e to the pi I, e to the pi I, that is 1, -1, I'm sorry. So -1 from the Euler's identity. So this one is -1 plus 2 ln of 2 minus 2 minus the lower limit ln of 1 is 0, and then we have minus 1. So that is going to be equal to 1 all over pi I e to the 2 pi. E to the 2 pi can also be written as what? So e to the 2 pi is cosine of 2 pi plus I sine of 2 pi. Minus minus, that's going to be plus 1 plus 2 ln of 2 minus 2 plus 1. So cosine of 2 pi is 1. That is cosine of 360. So which is 1. Sine of 2 pi is 0. So in the end, you have 1 plus 1 here. and then plus 2 ln of 2 minus 1. So we have 2 over pi I 2 over pi I plus 2 ln of 2 minus 1. So we can maybe take the rationalize the denominator here. So we have times I all over I plus 2 ln of 2 minus 1. And that is equal to what? So that is going to be negative 2I all over pi, because I times I is negative 1. So plus 2 ln of 2 minus 1. So this is how our integral can be reduced to. So the integral from 1 to 2 of negative 1 raised to the power x plus ln of x dx. This one really simplifies to 2 ln of 2 minus 1 minus 2I over pi. So this is a complex number. So if we integrate this integrand, that is what you are going to get. So if you like this video, please give me a thumbs up, subscribe to my channel for more engaging tutorial from integrals. I thank you so much for watching this video, and I will see you in the next one. Bye bye.